What is chemical kinetics? Right. So if you can see a slide here and read it out, what is that one thing in the universe that is constant? So can you tell? That is change, right? So what we see that now is very different from the years ago, right? So every day the things are changing, right? So chemistry, it also deals with the change on an atomic and molecular level through various chemical reaction. And that change we are going to study under chemical kinetics. So what is basically chemical kinetics? It is a branch of chemistry that determines the speed or rate of chemical reaction. Okay, that how much time a chemical reaction is taking to complete or to form a product, right? Suppose this is a point B and this is a point A and B, and suppose one person is standing here and he have to go from this A point to point B. Okay, in first case that he is taking his time. Okay, he is taking slow steps, okay, to reach at point B, right? Now what will happen here, the rate of changing its position from A to B, it will take lots of time, right? On the other side, if a person jumps from point A to B, it will take less time, right? So basically we discuss in what we discuss in chemical kinetic is at what rate or at what speed a chemical reaction is taking place, where time is the main factor. Okay, where time is the main factor. Okay, how time is the main factor? That suppose in a reaction where we left side are the reactants and they are forming products on the right side, that how much time or the reactants are taking place to form a product. What is the change in their concentration, initial concentration and the final concentration, and under what conditions they are going through to form a product. All right, how much time they are taking, reactants are taking to form a product. All right, so this whole change in chemical reaction, the speed and their rate, we are going to discuss in chemical kinetics. By kinetics we means the movement, right? And chemical, how the chemical reaction is actually moving or how it is happening, right? So this is what we are going to study in this chapter, chemical kinetics. So first understand what is rate of chemical reaction, okay? And then we will also discuss how we are going to calculate rate of chemical reaction, right? So let us first understand what is happening in chemical reaction. Let us start with an example. See, here is a reaction, okay, that are, say, any reactants, okay, they are forming some product, that is P, okay. Now initially the rate of firstly the rate of chemical reaction, it depends on the concentration of both the reactants and products, okay. Now initially when reaction is not taking place and we are having reactants, say A and B, they are forming some product, say P. Initially their concentration will be high, okay, because they are not used yet. But as the reaction is proceeding, okay, the concentration of reactant, they drop, right? Why? Because product is forming, okay. So at initial stage, okay, reactants concentration, that is high, okay. As the reaction is taking place, where product is having zero concentration. As the reaction taking place, the reactants concentration, it will decrease, and product concentration, it will increase. Understood? So basically, the rate of chemical reaction, it can be expressed in change of the concentration of reactants and in change in concentration of product. Here we have taken an example where reactants, they are forming some kind of product. Okay. So basically, in a chemical reaction, we check what? We check concentration. Okay. Now, how we calculate the rate of chemical reaction here? Okay, how we calculate the concentration, the change in concentration in reactants and in products, right? So as I have told you that time is the main factor. Okay, like how much concentration change in how much time, how much concentration is changing in how much time, that will determine the rate of chemical reaction. Okay, so basically what is rate of chemical reaction? It is the change of concentration divided by the time taken, okay, by the reactants to form a product, or by time taken by the whole reaction. All right. So how we calculate this rate of chemical reaction? See, for a reactant to form a product, there will be an initial state, right? Say reactants are forming product at initial state where time is zero, okay, and the concentration of reactants was also high, okay, and in the product side, initial timing say 0 because the reaction has not started yet, and product concentration, we write the concentration with square brackets, say the concentration of product is also 0. Okay, after some time, say the reaction is initiated. Let us say that final time for this reaction completion is 2, okay, 2 seconds, and here the product is formed, so the concentration of reactants, it will be used, okay, so the concentration of reactants, it will decrease, right, as the reactants, they are forming product. Okay, now the chemical reaction has taken place under some conditions, okay, at temperature, under suitable conditions of temperature and pressure, and then the product is formed. That product is formed, it will gain concentration from 0 to some point. Okay, whatever concentration of the reactants, they will provide the product will jump from its 0 concentration to some point, right? So how we calculate this whole rate of chemical reaction? Okay, by the change in time taken at initial state minus the time change in, or say, the final time. Okay, so for chemical reaction where reactants are forming some product, we calculate the rate by decrease in concentration of reactants and by time taken. Okay, time taken will be represented as delta T, which is what? Change in time. Change in time, for change in time there will be some final time and initial time, right? For calculating the change in concentration of reactant, this delta represent change and square bracket represent concentration. To calculate change in the concentration of reactant, what will that be? The concentration of molar concentration of reactant, or say final molar concentration of reactant minus initial molar concentration of reactant. Similarly, we calculate the change in molar concentration of product, right? P2 minus P1. Okay, that what is the product form at the final stage and what is the concentration of product at, what was the concentration of product at initial state, right? Now there is one point you need to remember is, if you see here, it is given that rate of disappearance of reactants. Why it is written disappearance here? Because as the reaction is, or the reactants they are forming products, they are getting completely utilized. Okay, the reactants they will get completely consumed to form a product, right? So that is why the rate of disappearance of reactants, we can calculate it as rate is equal to decrease in concentration of reactants, right, and the time taken, and it will always be a negative value. The rate of disappearance of reactants, it will always be negative value. Why? Because as I have said in the start, the concentration of reactants they will be high. Okay, as the reaction is proceeding to form a product, there is a gradual decrease in the molar concentration of reactants. Okay, say initial concentration of reactant was 1. Okay, and after it get consumed it will decrease, right? Say it was 4 at the start of the reaction, and as the reaction is forming a product, say the final concentration of the reactants, it decreases till 2. Okay, so how are you going to calculate the rate of, say this is initial molar concentration of reactants, say this is final. Okay, so how are you going to calculate that how much reactants they are consumed? By subtracting it, right? So if you subtract this value, that final minus initial, okay, it will always be a negative value, right? But in case of product, as it is increasing its concentration from 0 to some point, okay, so that is why it will always be a positive value, because the concentration is increasing at the product side. I hope it is clear now that why we take the concentration of reactants a negative value. All right, why? Because R2, okay, that is say final reactant concentration, it will always be smaller than the concentration of R1, molar concentration of R1, that is molar concentration of reactant, initial reactant, right? Why it is always smaller? Because reactants they are continuously getting consumed in a chemical reaction to form a product. And why the product concentration is always positive? Because the product concentration it is always increasing. Okay, because the products initially it was at 0 state, and after some time with the reaction with the reactants showing chemical reaction, the products start forming. So rate of appearance of product, it will be increase in concentration of product by time taken. Okay, that is again the same T2 minus T1, that is delta T. Okay, it will be a positive value. And what is RAV? It is average rate of reaction dependent on concentration and time taken. Okay, right. Now if we look at the diagram here, we have plot a graph for rate to understand the rate of chemical reaction. All right. Now this is a product formation. This is a graph of product formation. Okay. This is a graph of product formation. Product formation. Okay. Where you can see that this side we have taken the concentration and this is time on the x-axis. So this is basically concentration versus time graph, right? So if you look closely at it, here we are having product that is P1 and product that is P2. Here we are having product at initial stage at time t, okay, and we are having product formed that is P2 at time t2 at different times. All right. Now, how we calculate the rate of change in the concentration of product? You see here the concentration of product was less, say it is 1, okay, and here it is continuously increasing as the reactions is going on, okay. So as you can see here, the P1 molar concentration, it has increased from 1 to 2. All right, so this is the reason how we are going to calculate the change in the molar concentration of product. Same formula with respect to the time, that at time t, say time at 5 second, the concentration of product is 1. At 10 second, the concentration of product, it has increased to double, say 2. All right. So we are going to calculate the product concentration by the same formula, delta P by delta T, that is T2 minus T1, and product formation final minus initial, right? Concentration of P2 minus concentration of P1. Okay. And this concentration, this way of writing rate of concentration, delta P by delta T, this is known as average rate concentration. Okay, this is known as rate of, or say average rate, okay, or say average rate of reaction, which is dependent on concentration and the time taken. All right, where we can find the concentration of these 2 points, okay, by subtracting the molar concentration of product at final stage and final minus initial concentration, right? Now there is one more thing. We can see here it is written rate instantaneous, that is instantaneous rate, which is like this. Now what is this? If you have to, now for average rate we can calculate it by the difference of different times, okay, by taking the difference of 2 different times we can calculate the average rate. But if we have to calculate the rate of chemical reaction at a particular time, okay, at a particular, say, second, that I have to calculate what is the rate of reaction when time was 3 seconds, okay. For that instantaneous movement, for that to calculate that instant particular time, we use this formula, okay, that is dp by dt, okay. The change in, or say small change in the product molar concentration of product with respect to change in time. This is the formula of what? To calculating instantaneous change in instantaneous rate change. All right. This graph represent the slope that is continuously increasing, the concentration, molar concentration, slope of product that is continuously increasing, and the value of product, calculating the concentration of product, it is always positive. Now if we look at the reactant side, as the reactant it start consuming to form a product, their concentration is decreasing, right, gradually. It is shown here in the graph, okay. As the value, or say the molar concentration of reactants, they are decreasing, and the reactants they are losing its concentration to lower value, we take rate of chemical change in reactant side as negative value. All right. Now I hope this is understood now. Okay. Similarly, for instantaneous rate, we can calculate instantaneous rate, same formula but with a negative sign. Okay, small change in the molar concentration of reactants with respect to that instantaneous time. All right, and to calculate the average rate of a chemical reaction at the reactant side, we can use the change in molar concentration of reactant with the negative sign. Why? Because, tell me why? Because rate of molar concentration of final step, or say final stage, it will always be smaller than the initial step, right? And the slope for this will always be negative, okay, for the reactant side, right? So let us take an example here to understand how we write the average rate and the rate of instantaneous rate. Say if I write here an example, or say a chemical reaction, it is also given here the basic, but let us start with the simple example. Here I am taking C4H9Cl with water. Okay, these are the reactants and they are forming a product C4H9OH, okay, with HCl. Right. Now how are you going to write the average rate for this reaction? For reactant side, it will be minus delta the, that is change in the molar concentration of reactant by change in time, right? And that for product side, it will be change in molar concentration of product by change in time, right? Now if at time say t is equals to 0, that at this specific time we have to find the rate of chemical reaction, that will be instantaneous rate, right? And it will be equals to minus d rate molar concentration of reactants by dt, and that of product side it will be dp by dt, right? Understood here? Okay. How we can write concentration for these reactants? For this specific reaction, we can write by putting these reactants here. All right. Right. Now, if we look at this reaction where we are having AA, where A is what? This small a is what? This is a stoichiometric coefficient. Stoichiometric coefficient of A. Similarly, B is having stoichiometric coefficient, C is having stoichiometric coefficient small c, and D is having stoichiometric coefficient, okay, small d. All right. For this, how we can write instantaneous rate reaction or average rate reaction? Yes, it is written here. For a reactant side, this reactant side is what? A and B. For that, we can write the this stoichiometric coefficient. We are going to write it as 1 by A. Okay, and that for reactants with the molar concentration dA by dt. Similarly, for B, with the negative sign. Why? Because reactants, okay, we write the change in molar concentration of reactant with negative sign, and that for the product side it will be a positive value, right? So let us try to write rate of chemical reaction for this example. Mercury and chlorine, they are combining and forming HgCl2, mercury chloride, right? How we are going to write rate for this reaction? Yes, tell me. For reactant side, it will be minus delta and the molar concentration of reactant, right? This is reactant reaction, rate of reaction for reactants. Okay. And for Cl2, it will be like this, right? And for the product side, you can write, right? It will be delta HgCl2 by delta T. Understood till here? Let us now write, this was a simple example. Let us do one example for with stoichiometric coefficient. Let's see if you are able to write the rate of chemical reaction equation for them or no. Okay. Let's take an example of 2HI that give rise to H2 and I2 molecule. Can you write rate of chemical reaction for this? Reaction rate of reactants, it would be what? Now this is what? This is a stoichiometric coefficient. How we are going to write for reactants? First of all, negative sign. Then the stoichiometric coefficient by reciprocal, that 1 by 2. And then, yes, delta, that is change in concentration of reactants by time. Understood? For product, it will be the same. That is delta H2 by delta T. Understood? Right. Right. Before moving forward, let us do one more example. For this, 5Br negative plus BrO3 negative, okay, plus 6H positive. Now these are all the reactants and they are forming a product 3Br2 plus 3H2O. Okay, now I want you to write rate of chemical reaction for this equation, right? I hope you can write, right? For reactant side, this will become negative, that is, and for coefficient, we are going to reciprocate it. Minus 1 by 5 change in the molar concentration of Br by delta T, right? You can write it now, right? So how we mainly write the rate of chemical reaction? I hope it is clear now. By the decrease or by any change in the concentration of reactant, okay, by the time taken, that is delta T, and the change in concentration of the product, okay, by the time taken. Understood?